By 1973, International Harvester rolls out a 303 horsepower articulated tractor and immediately finds the hydraulics leaking, the frame groaning, and a competitor from Fargo, North Dakota already building something better. By 1970, grain operations on the Great Plains were expanding faster than the machines to work them. Federal policy and rising export demand pushed large farms past what any 150 horsepower row crop tractor could handle in a season. The industry knew 200-plus horsepower was coming. What it didn't know was what that power would break on the way there. 3 companies answered in parallel, from completely different positions. International Harvester arrived with the largest budget and the deepest dealer network in the country. The IH-4-366 ran a 303 horsepower DT-466 V8 and looked like the logical product from a company that size. In the field, the hydraulic system couldn't handle cyclic stress under sustained deep tillage. Seals leaked, pressure dropped. More critically, at the central articulation joint, the structural pivot the entire steering geometry depends on. The frame was developing microfractures under full drawbar load. Mechanics recorded the damage before 300 engine hours. IH's service network, built around conventional row crop equipment, had no real infrastructure for a machine this large. The support system that worked for the 1066 was a full season behind what the 4366 actually needed. In Fargo, Steiger was building the Bearcat ST225 with no proprietary components at all. Cummins engines, Clark axles, Spicer drive shafts. Parts available from any industrial supplier within a day's drive. When something failed, a farmer didn't wait on a factory spec order. He sourced it locally and got back in the field. Steiger had already built 126 tractors by hand on their own farm before opening a factory in 1969. By 1970, 66 dealers covered North America. The machine looked utilitarian. It was also fixable, which turned out to matter more than how it looked. John Deere came with the one thing neither IH nor Steiger offered: a sealed cab. The 8630's sound guard body dropped operator noise from around 115 to roughly 88 decibels, a genuine leap for anyone who'd spent a harvest season on an open platform. But the cab added 300 to 400 kilograms directly above the articulation joint. The hydraulic pump, positioned in the zone between the cab and the front axle, overheated under sustained load cycles. Operators described the same symptom. The tractor would lose implement pressure mid-pass, exactly when it needed to hold firm. Catalog output was 15 acres per hour. After 200 engine hours, real-world performance settled around 10 to 11, interrupted by regular stops to let hydraulic pressure recover. 3 machines, 1 unsolved problem, 3 different failure points. The one assembled from borrowed industrial parts outlasted the one backed by a full corporate R&D department. By 1975, both IH and Deere were drawing from the architecture that 2 brothers from North Dakota had worked out on a family farm. The central articulation layout, the standard commercial components, the frame-first design logic. Nobody publicly credited them for it. By the mid-1970s, the architecture question was settled. Articulated center pivot frame, commercial spec drivetrain, purpose-built for large acreage. What wasn't settled was how far you could push that architecture before it stopped cooperating. The Steiger Cougar ST300 became the answer for most of the grain belt. 300 horsepower placed it exactly where 1,500 to 3,000 acre operations needed a machine, large enough to move ground at scale, not so large that one breakdown stopped a harvest. The central articulation joint ran on 2 vertical bolts working against lateral shear loads they weren't designed to handle indefinitely. By 800 to 1,000 engine hours, mechanics were documenting 2 to 4 millimeters of play in the pivot. The Cougar 3, updated with an Allison power shift in 1985, cut transmission failures sharply, and doubled the repair bill when the Allison eventually needed work, because not every Steiger dealer had a certified Allison technician on staff. The cab was a separate issue. Early Cougar models ran Cummins without meaningful sound insulation, 110 to 112 decibels at the operator station. The OSHA recommended daily exposure limit for that level is under 4 hours. Operators were running 10-hour shifts. Steiger didn't address it systematically until the mid-1980s. Northern Manufacturing in Havre, Montana, was building something no Cougar could touch on horsepower. The Big Bud 525/50 ran a Cummins KTA 1150 at 525 horsepower and weighed over 30 tons. The plant produced dozens of machines per year, not thousands. There was no dealer network in the conventional sense. Parts came directly from the factory or through Cummins and Allison distribution channels, with lead times measured in weeks, not days. The weight created a problem nobody had clean data on yet. 30 tons on 4 wheels, compacted subsoil, at depths 1970s, agronomy hadn't fully characterized. The yield penalty didn't show up the first season or the second. It appeared 5 to 7 years later, when fields under sustained heavy-wheeled traffic started recording lower outputs on the same ground. That pattern became one of the primary arguments for tracked platforms in the following decade, a bill that arrived long after the machine that generated it had moved on. Then there was the Big Bud 1650 747, one machine, built in 1977, Detroit diesel 16 VUF, 92 T 24.1 liters, 960 horsepower gross, 100,000 pounds, 6 meters wide. Designed for a cotton operation in California's Central Valley. Flat ground, 80-foot implements, no turns. The turnaround at the end of each pass took longer than a 400-meter run through it. No spare parts existed on any shelf anywhere because there was no shelf. A major drivetrain failure meant a direct call to Havre. The machine is still running today, upgraded past 1,100 horsepower. But it never became a platform or a precedent. It became a single-line proof. Given the right terrain and no budget ceiling, there is no upper limit. That's a categorically different claim than anything the Cougar was making. And both happened to be true at the same time, in the same industry, with almost nothing else in common. By the late 1970s, the articulated center pivot frame had won the format debate. Every serious player in this class was building around it. What they couldn't agree on was where the joint should sit, and that disagreement produced the most technically aggressive, most expensive, and most rapidly failed experiment in this entire story. International Harvester's 4786 and 4986 were straightforward escalations. 335 to 350 plus horsepower, bigger block, same architecture. The cooling system wasn't redesigned for the thermal load. In summer conditions above 35 degrees Celsius, standard for Kansas, standard for Texas, the radiator couldn't shed heat fast enough during sustained heavy cycles. Operators learned to watch the temperature gauge the way you'd watch a pressure valve. The hydraulic valve block leaked under sustained pressure, with enough consistency that field mechanics treated it as scheduled maintenance rather than a failure event. IH never solved either problem before the series ended in 1984. The following year, the entire agricultural division was sold to Tenneco. The IH2+2, the 3388, 3588, and 3788 was something different. Instead of placing the articulation joint at the frame's midpoint, IH moved it forward, directly in front of the cab. The operator traveled with the front axle. Steering feel improved. Fatigue dropped. On paper, it was a genuine step forward in how a driver experienced a 300 horsepower machine over 10 hours. The execution collapsed in 2 places. First, the 16-speed transmission was inherited from the 1086 row crop line and hadn't been re-engineered for the torsional loads the new joint geometry created. The torque amplifier dropped to low range under load, predictably, repeatedly, with no clean fix. Second, the turning radius was 30 to 40% wider than a conventional articulated competitor. On small or irregular plots, the machine was effectively unworkable. Production closed in 1984, 5 years in, with no successor. The concept outlived the company's ability to finish it. The Steiger Panther CP1325 arrived with Allison power shift and 325 horsepower. The CP1400 pushed to 400. At that load, a 14-bottom plow on hard clay ground, The frame received twisting forces that exceeded the structural calculation at the articulation bolts. The bolts sheared in the field. Repair. 4 to 6 hours minimum, without a torque wrench, under open sky. The frame cross-section that worked for the Cougar wasn't proportionally scaled for 400 horsepower. It was the same frame, carrying more than it was designed to carry, and the math eventually caught up. By 1983, Steiger was running the Fargo plant at roughly 25% capacity. Farm bankruptcies across the Midwest had collapsed new equipment demand. The Panther didn't fail because of the sheared bolts. It stopped selling because the farms that needed it stopped existing. 3 machines, 3 different exit stories. None of them left production because they technically failed. All 3 left because the world around them changed faster than the companies building them. The Steiger Tiger 3ST470 ran 470 horsepower through a Clark powershift transmission that had already demonstrated its limits in the Panther. The Tiger 4 KP525 fixed that by switching to Allison and pushing output to 525 horsepower, the highest rating on any production articulated tractor at the time it shipped. The frame was heavier than the Panther's, which meant the articulation bolts survived an 18 to 20 bottom plow where the CP1400 had sheared. Survived, not thrived. The joint still accumulated wear, faster than the rest of the machine under full drawbar load. In 1986, Steiger filed for bankruptcy and sold to Tenneco. The factory in Fargo transferred to Case Wamwine-H. The Bearcat, Cougar, Panther, Tiger. All of it gone as brand identity overnight. In the first year after the acquisition, cross-reference catalogs between old Steiger part numbers and new Case, in H numbers weren't ready. Dealers on both sides spent weeks identifying components that hadn't changed physically, but had been renumbered entirely. The John Deere 885-0 is the machine that mechanics still talk about, and not only because it's rare. Deere built one generation of V8-powered 4WD and never returned to the configuration. The reason is structural. In the 8x50 series architecture, the engine block is a load-bearing frame member. The front axle bolts directly to the block. Under articulation at maximum drawbar load, the full twisting force of the drivetrain transferred into the engine casting. Cracked blocks and failed main bearing journals appeared between 3,500 and 5,000 hours. Not gradually, but suddenly, without useful warning symptoms. The V8 also ran hotter than the inline-6 competitors it replaced, and the radiator configuration wasn't revised to match. On sustained grades in summer conditions, thermal management was marginal. Deere rated it at 370 horsepower at Nebraska. In hard ground conditions with thermal cycling, operators were getting 310 to 330 effective horsepower before mandatory cool-down stops. The 885-0 now sells at auction for more than comparable new tractors. Scarcity drove the price up. The cracked block problem drove the production run down. Northern Manufacturing's Big Bud 740 arrived in 1987 with a twin-disc hydrostatic transmission and 740 horsepower. Hydrostatic drive was technically correct for a machine this heavy. No shock loading on gear changes, continuous torque adjustment, better efficiency at variable speeds. The problem wasn't the technology. Northern Manufacturing had been sold to Meissner Brothers in 1985 with no development budget remaining. The 740 was the last attempt by a dying company to stay in a market that had already moved on. The last Big Bud came off the line in 1992. Not because the machine was wrong, because the company had no runway left to sell it. The consolidation that ended Part 4 didn't just change logos. It reset the competitive field to 2. By the early 1990s, anyone buying a high-horsepower, articulated four-wheel drive in the United States was choosing between Case Wine-H, running Steiger's platform out of the same Fargo factory, and John Deere. Every other independent producer from the 1970s was either absorbed or finished. The mechanical platform was mature. What came next was a layer of electronics placed on top of it by engineers who understood software better than they understood what a wheat field does to an unsealed connector over 3 harvest seasons. The Case IH Steiger 9370 and 9390 carried Steiger's chassis architecture in red paint. The mechanical foundation was already a decade old when the series launched in 1997, well understood by experienced dealers. What wasn't understood yet was the first-generation TECU, the tractor electronic control unit managing hydraulics and transmission. The housing wasn't adequately sealed against the particulate environment of dry tillage. Dust infiltration caused control unit failures that shut down hydraulic and transmission management simultaneously. A field mechanic without a diagnostic laptop couldn't determine the cause or restore the system. The GPS auto steering case. IH, integrated into this series, was ahead of the competition on timing and behind on execution. In multipath signal conditions, broken terrain, or proximity to steel structures, the antenna lost fix and the steering correction could snap hard before the operator caught it. The recovery sequence back to auto mode had no clean procedure. Operators learned to disengage it on anything but flat open ground. The John Deere 9400 introduced independent front axle suspension to the 4WD class, a genuine comfort improvement on rough terrain that no previous machine in this segment had offered. The ride changed. Operator fatigue over a 10-hour shift dropped measurably. Then the suspension pivot pins and bushings met sustained heavy tillage loads, and the failure interval turned out to be shorter than a comparable rigid axle system. A front suspension repair that previously took 2 to 3 hours on a straight axle now required lifting equipment and 6 to 8 hours. The cab sealing on early units degraded faster than expected under UV exposure. After 2 or 3 seasons, condensation and dust worked back in through deteriorated door and roof seals, creating the same interior environment the sealed cab was supposed to eliminate. The 9600 and the later 9020 series peaked at 450 horsepower, a Deere record at the time. The Tier 1 engine delivered that rating reliably under one condition: maintenance intervals observed exactly during harvest. Crews running through peak season without oil service calls were documenting accelerated bearing wear in post-season teardowns. Both platforms marked the same threshold, the last generation where a knowledgeable field mechanic could diagnose most failures without external equipment. After 1997, fault codes required a laptop. The diagnostic skill that American farm mechanics had accumulated across 50 years of working on this class of machinery stopped converting directly into the ability to fix it. That shift was quiet, incremental, and permanent. The horsepower race ended quietly. Both remaining players arrived at 620 within a few years of each other, looked across the market, and found nobody left to race. What replaced the power competition was a different kind of competition, over who owns the data the machine generates, and what the farmer can do without asking permission first. The John Deere 9R covers the wheeled platform from 450 to 620 horsepower. The 9RT introduced a centrally mounted dual-track system as a middle path between wheels and full tracks. The 9RX went further. 4 independent track units, each with its own hydraulic drive motor. Ground pressure below 9 psi, less than a person walking the same field. The compaction problem that the Big Bud 525/50 quietly created across the late 1970s, and that agronomists were still documenting a decade later, is genuinely solved at the engineering level. The trade-off is structural. 4 independent drives mean 4 hydraulic circuits, 4 sets of sensors, 4 points of failure that each individually immobilize the machine. When one motor goes down in the field, the 9RX doesn't limp. It stops. Recovery requires a certified technician with access to John Deere's Service Advisor system. The PowerShift 16x4 transmission logged a separate documented issue: premature clutch pack wear when the electronic shift calibration drifted out of spec, generating impact loads the packs weren't rated to absorb. The symptom appeared between 800 and 1,200 hours. The diagnosis required the laptop. The fix required the dealer. JDA Link formalized what had been drifting toward this point since the 9400. As of 2012, reprogramming the ECU requires John Deere authorization. A failed sensor worth under $150 in parts cannot be addressed independently if clearing the fault code requires proprietary software access. Dealer labor for electronic diagnostics runs $250 to $350 per hour. The machine costs $600,000. The dependency is total and by design. The Case IHAFS connects Steiger 620 and QuadTrack 620 operate inside the same logic. AFS Connect offers two-way telemetry, data flowing from the machine to the dealer and back. In practice, the return channel functions only when the dealer is actively monitoring. A documented 2020 case, a new QuadTrack 620. First day of harvest, halted by a fault code, the attending dealer could not resolve without factory-level support. Total downtime exceeded 24 hours. The machine cost more than most farms earned in a year. A direct line runs from a hand-built Steiger Bearcat on a North Dakota farm in 1958, through the Fargo factory that opened in 1969, through the Case 1H acquisition in 1986, through CNH Industrial today. Same building, same ground, 65 years of continuous production. The mechanical evolution is unambiguous. What changed is the terms. The farmer who once fixed the machine with parts sourced locally now operates equipment he owns but cannot fully service. The right to repair legislation that moved through multiple state legislatures between 2021 and 2024 didn't emerge from ideology. It emerged from operators who remembered what it felt like to be competent and noticed when that stopped being enough.